Hi there and welcome to our next lesson on C1 carbon chemistry, and during today's lesson what we're going to be looking at is clean air. Now we're going to be looking at how the composition of the atmosphere, so the gases that are in the atmosphere, have changed over time, and what new gases that we are putting into the atmosphere, what effect they might have on the gases in the atmosphere. So our objectives for today's lesson on clean air is, by the end of this lesson you should know and understand how the atmosphere has changed over time and how chemicals can change the makeup of the atmosphere. Now the Earth is about 4.5 billion years old, and what we've got here is a timeline that stretches 4.5 billion years ago. Now right here we've got the beginning of time, and now we've got here today, and what we're going to look at is the gases that were in the atmosphere at a particular time. Now in the first stages of the Earth's atmosphere there were large amounts of carbon dioxide and ammonia. Now it's thought that these gases came from inside the Earth, from volcanoes, where all the gases were being made and then produced and left into, or put into, the atmosphere, and it was mainly carbon dioxide and ammonia. However, it's also believed that there may have been small amounts of methane gas as well. Now after about 1 billion, half a billion years, there was a cooling of the Earth. So because we had all these hot volcanoes in the early section, there was then a cooling when the Earth started to get colder. Now it's believed then that water that was in the atmosphere then condensed to make the oceans. So then we had all of this water that fell from the sky as rain, and we had the oceans. So the oceans actually came from gases in the atmosphere. Now with the development of oceans we were then able to get very small, simple bacteria and plant cells. Now it was these bacteria cells that were then able to start reproducing in the water, and what they were able to do is start to photosynthesize. Now this is happening at around about 3 billion years ago. So it's taken 1.5 billion years to start to get this. Now what that causes with photosynthesis is the carbon dioxide that's in the atmosphere is used up by the bacteria, and then we start to produce oxygen. So the amount of carbon dioxide drops and the amount of oxygen starts to increase. Now once the bacteria cells have started to form, we then get the plant cells, which are able to photosynthesize even more. So we start with the bacteria, then we start with the plant cells, and that removes still removes the carbon dioxide and adds the oxygen into the atmosphere. Now it's not until a lot later on that we start to get the plant cells that are able to convert this ammonia into nitrogen. Now the nitrogen is very unreactive. Now the plant cells are able to convert this ammonia into nitrogen, which isn't reactive, so we start to get a build-up of nitrogen in the atmosphere. Now because of photosynthesis and respiration, we have a leveling off of the amount of oxygen that's produced and the amount of carbon dioxide that is removed, but the nitrogen, which is unreactive, starts to increase, and that's why today our atmosphere is made up of 78 of nitrogen and about 20% of oxygen. And then there's also 1% argon, which is very unreactive. However, there is still carbon dioxide, but the amount of carbon dioxide is very, very small, and it's 0.035%. And that's how we've got the atmosphere that we have today. Now, air pollution is pollution or gases that we put into the atmosphere that can have an effect on the composition or the makeup of the atmosphere. Now, they can include several different types of material. Carbon monoxide is one, nitrogen dioxide is another, and unburnt hydrocarbons is a third. Now, all of these come from car exhausts. Now, there are further pollutants which include oxides of nitrogen. Now, this can cause something called photochemical smog. Now, if you look into a city and you can see a red haze across the city, you might be able to see it if you're up on Dartmoor looking into Exeter. You might see that photochemical smog, which is the red colour. And we've also got aerosols, which can cause the damage to the ozone layer. Now, the oxides of nitrogen can also have an effect called acid rain, which you've probably heard of. Now, what this does is the gases, which can include oxides of nitrogen but also sulfur dioxide, which can cause acid rain when they mix with the water. Now, the effect of these can include damage to stonework, corrode or corrosion of metals, acidifying water, which can kill plants and animals, and it can also kill plants that are not in water as well. Now, in terms of pollution nowadays, there is a lot of emphasis and political persuasion that there's human contributions to pollution. Now, there are three main factors that you need to consider, and these are with an increase in burning of fossil fuels. Now, when we've talked about combustion, we know that we get an increase in carbon dioxide, and it's believed that carbon dioxide contributes to global warming. So an increase in burning fossil fuels will mean that we get more carbon dioxide. The second influence is the deforestation, so reducing large amounts of rainforest to make more land for building. Now, with that deforestation, you're removing trees that take in the carbon dioxide for photosynthesis. Now, if you remove that, you've got less photosynthesis going on, so you end up with more carbon dioxide in the atmosphere. Now, the third human factor is an increase in world population. Now, because of an increase in world population, we need more land to live on, so we end up cutting down more trees. We also need more fuels to burn, so we get an increase in burning fossil fuels. Now, catalytic converters are put into cars to remove some of the pollutant gases that come out. Now, two of the main pollutant gases that come out of a car engine is carbon monoxide and nitrogen monoxide. Now, what they do is they react together to form nitrogen and carbon dioxide, which are said to be less polluting than the carbon monoxide and the carbon dioxide. And this creates a balanced symbol equation of 2 lots of carbon monoxide reacts with 2 lots of nitrogen monoxide to produce 1 molecule of nitrogen and 2 molecules of carbon dioxide. And the carbon dioxide and the nitrogen are going to be less harmful than the carbon dioxide and the nitrogen monoxide, as this will only cause global warming, whereas this will cause acid rain. In fact, both of them can cause acid rain. Okay, so that's the end of the lesson on clean air, where we've looked at the evolution of the atmosphere and how the atmosphere has changed in the 4.5 billion years since it's been around. We've also looked at how humans have influenced it and the possible pollution problems that we face today. Anyway, I hope you've enjoyed this, and I'll see you next time. Bye-bye.